Seventh graders, lesson 4.7 is about multiplying numbers with exponents, and specifically multiplying numbers with exponents that are have the same base. Okay? So, if you look at this example, it says simplify m to the third power times m to the fourth power. It's just m to the seventh power, right? The rule is that you can add the exponents when the bases are the same. So since they're both have a base of m, you can just add 3 plus 4. Okay? This is how you would write that out in expanded form. M to the third, m times m times m, right? M to the fourth, m times m times m times m. So you're just counting up all of the m's that are being multiplied together. Okay?
What if it was m to the third power plus m to the fourth?
Okay, that's different. If it was plus in between instead of times, then you'd have to keep them separate. Okay? Then you'd have to find the answer to each one and then add those two answers together, not multiply them together. Okay? This is only when powers with the same base are being multiplied together. So that's a good question. All right? Then, sometimes you will see a power of a power. A power of a power. And that means that you have the power of x to the third, then that taken to the fourth power. So now we have x to the third to the fourth power. Alright? So that means x to the third times x to the third times x to the third times x to the third. Or it means x to the 3 times 4, which is x to the 12th. Okay? So think of it. A power of a power is multiplying the 3 times 4, because the x to the third is being multiplied by itself 4 times. X to the third to the fourth power. And so then you multiply the exponents together to get the answer. Okay? Do you see the difference in the way that it's written? This one has the power right outside of the parentheses, and this one doesn't have parentheses at all. Okay? What's that? When you're done.
If we write it either way, or do we have to write it as
Well, what you're going to be asked to do is simplify this by writing it as one answer. So the question will be simplify x to the third to the fourth power. And so you would write, that's x to the 12th. Okay? You might have to simplify expressions with more than one kind of base. So, for example, page 209, I know you have your book open, most of you, page 209. As I said, open to page 209, lesson 4.7. Lesson 4.7, yep. And at the bottom of the page, sample C. That one is x to the second times x to the third times y to the fourth. X to the second times x to the third times y to the fourth. So which ones can you combine? Which ones can you combine in this one? Can you combine the x's and y's? Which ones can you combine? And what is the power of this one? That's just y to the first. So how many total y's are there? Katie. Y to the first times y to the fifth. What did you say? Y to the first times y to the fourth. So 1 plus, oh good, I couldn't hear you. I think it's because of all the gym noise. That's y to the fifth. Yep. And this is being multiplied by x to the fifth. Okay? The way you can figure it out is to think of them in expanded form. This is x times x times x times x x. There's 5 of them. Times y times y times y times y times y. Okay? Does that make sense, everybody?
Yeah.
Thumbs up if you're if this one makes sense. Okay? Now, turn the page.
Macaroni and Cheerios.
Look at example 2. This one has some numbers in it. Negative 2x squared times 3x to the 5th power. Now, can we change the numbers around? Can we change the order of the numbers? Aiden, show me slant. Yep, sit up. Eyes up here. Can we rearrange the order of the numbers when we're multiplying? What property says you can switch the order of the numbers when you're multiplying? Kaden? Commutative property, right. So we could write this out as negative 2 times 3 times x squared times x to the 5th, right? Can we write it out this way? Is that legal? Michael?
Yeah.
Yep. Good. So now can we combine them? Devlin?
2x and 7x.
Yeah, x to the 7th. Good, because we just add the exponents. And then negative 2 times 3 is